This is a good place to discuss how figures are expressed in engineering in general and in electronics in particular. Let's start with very large ones. Numbers which are in the thousands can be prefixed by kilo, represented by a small k. So 1000 watts, for example, can be written down as 1 kilowatt. It can also be written down in scientific notation as 1 times 10 to the 3 watts. So the prefix kilo can also be taken to mean times 10 to the power of 3. To take another example, 250,000 volts is 250 times 10 to the 3 volts, or 250 kilovolts. Similarly, the prefix m, which means mega or 1 million, is times 10 to the power of 6. So 7 million watts is 7 megawatts, or 7 times 10 to the power of 6 watts. A billion, that is an American billion, which is 100 million, is times 10 to the power of 9 and given the prefix giga. So, for example, 2 gigahertz is 2 billion hertz, or 2 times 10 to the power of 9 hertz. The next prefix up is 100 billion, or times 10 to the power of 12, and is a tetra, but this is quite a large unit, and so you may not come across it very often. And there are even larger ones if necessary. So what about very small figures? 1,000th of something is a milli, which is times 10 to the power of minus 3. So for example, 2 milliseconds is 2 times 10 to the minus 3 seconds, or if you like, 0.002 seconds. The next prefix down, which is 1,000th of this, is millionths, or times 10 to the minus 6, and is given the prefix micro. Further down from this again is a billionth, times 10 to minus 9, which is given the prefix nano, and then pico, which is times 10 to minus 12. This is probably the smallest you're likely to come across. However, there are even smaller ones if necessary, the next one down being a femto, which is times 10 to the minus 15. Notice they go up and down in thousandths, and I'll provide a little table here just to show you how they range. I'd like to discuss something else in this video which is closely related. Sometimes we have to deal with very large or very small numbers in electronics, and it's not convenient to do it with the system that I've just outlined. For example, consider an amplifier with an amplification of 10 million. This means that the output is 10 million times bigger than the input. An amplifier is a circuit which makes signals bigger. So if we put in 1 milliwatt to the input, we'd expect 10 watts to come from the output. We can't easily use prefixes as I've just discussed, because this would be written as 10 mega, but 10 megawatt, the amplification doesn't have a unit because it's watts divided by watts. So an alternative is to use decibels, abbreviated dB. dBs are used to express very big ratios of very small ratios, like the example we've just used. And they're given by the following formula. The dB is equal to 10 log to the base 10 of a ratio which we're trying to describe. So in this case, the decibels is equal to 10 log to the base 10 of the output power divided by the input power, which, if we remember, is equal to 10 log 10 of 10 watts divided by 1 microwatt, which is equal to 10 log 10 of that ratio, which is 10 times 10 to the power of 6, which is equal to 70 dB. Now it's easier to remember 70 dB than it is to remember a big figure like 10 million. Some common dB ratios are shown in a table here, just to give you an idea of what they stand for. Note, however, that the formula dB is equal to 10 log 10 of a ratio only applies to powers. If we're talking about voltages, the formula is that it's 20 log to the base 10 of a ratio. Sometimes a unit is placed after the dB to show how much bigger a measurement is than that particular unit. As an example, 3 decibel milliwatts is equal to 6 milliwatts. In other words, it's 3 dB larger than 1 milliwatt. And 10 decibel milliwatts is equal to 10 milliwatts.